So the octet rule says that atoms tend to gain, lose, or share electrons until they have 8 electrons in their outer energy level. So sodium has 1 valence electron. Remember, valence electrons being the electrons in the outer shell, and chlorine has 7. So sodium is likely to lose 1 valence electron to chlorine and have 8 electrons in its new outer shell, which would be this one, while chlorine would gain that one to have 8 in its outer shell. So some atoms, such as metals, tend to lose, and nonmetals tend to gain these electrons. When electrons are transferred, a charge is formed. A charge is represented with the actual charge being positive or negative of the atom, or in this case ion now, and the number of electrons gained or lost. So for this one, first it says, what element is this? You can figure out what element it is by the number of protons always. Because remember, the protons do not change. Then, how many valence electrons does it have? It has 1, 2, 3, 4, 5. So, looking at the periodic table, 7 protons corresponds to nitrogen. And 1, 2, 3, 4, 5 valence electrons. So would it most likely lose 5 or gain 3? It would most likely gain 3 to get that full octet. So anytime it's gaining an electron, remember from part 1, we said that's going to be a negative charge because we're gaining something negative. And how many? 3. Therefore, the charge would be a negative 3. Go ahead and pause the video, figure out those same questions, but for this Bohr diagram. Looking at the periodic table, it had 3 protons, which corresponds to lithium. You can clearly see there's 1 valence electron. So it should be losing electrons, and it needs to lose 1 to have a full outer shell. So since it's losing, it's going to be a positive, and it lost 1, so positive 1. We don't want to draw Bohr diagrams, though, all the time to figure out what charge elements are going to make. Just like we don't draw Bohr diagrams to figure out how many valence electrons each family has. Remember, from the periodic table video, we said that this column had 1 valence electron. This column has 2 valence electrons. 3, 4, 5, 6, 7, 8, with the exception of helium, which only has 2. So if that's how many valence electrons it has, this family, the alkali metals, would most likely lose 1 and have a positive 1 charge. These would lose 2 and have a positive 2 charge. The noble gases already have a full outer shell, so they're going to be a 0. They don't react. The halogens have 7, so they need 1 more to get to 8, so they're going to be a negative 1 because they're going to gain 1. This group has 6, they need to gain 2, so they're going to be a negative 2. This one will be a negative 3, and when we say negative 3, it's only going to the nonmetals. So those are negative 3. These will be negative 4 because they need to gain 4. And remember, nonmetals tend to gain. These below it have 4 as well, but they're probably going to lose 4 because they're metals. So if we want, we can fill it in this way just to know that it's only going to the nonmetals. There's a few transition metals that we do need to know the charge of. Silver is always a +1. Zinc and cadmium are always +2s. And aluminum and gallium are always +3. These other metals that are transition and underneath here have variable charges, meaning that their charges change. We'll talk more about them in just a few minutes. So on here it says determine the charge of each element below after it gains or loses electrons. So calcium, if we look on the periodic table, it's in this column. So since it's in this column, it should always lose electrons and form a positive 2 charge. Remember, your metals are going to be positive and your nonmetals are going to be negative. Go ahead and pause the video and figure out the charge for these other 5. Restart when you're done. Okay, so first nitrogen was here, potassium was here, oxygen, magnesium, and aluminum. So nitrogen, you should have said, was a -3. It's 0, -1, -2, -3. Potassium was in group 1A, so it should be a +1. Oxygen was 0, -1, -2. Magnesium should have been a 1, 2. And aluminum 1, 2, 3, or +3. To name our ions, we have a couple of rules. The first thing you have to ask yourself, if it has a positive charge or is a cation, is it group 1A, 2A, silver, zinc, cadmium, aluminum, or gallium? If you notice, those are group 1A, group 2A, silver, zinc, cadmium, aluminum, or gallium. Those are the only metals that we know the charge of. So we're just going to name it, saying calcium ion, or magnesium ion, zinc ion. But if the metal is not listed above, we have to use Roman numerals to indicate the charge. So iron is here. It's in the middle. It's not silver, zinc, cadmium, aluminum, or gallium. And so we have to use Roman numerals to indicate the charge. So since that's a 3, we say iron 3 ion. You only have to know 1 through 5 for Roman numerals. We have 1, 2, 3, 4, and 5. So notice copper is right in that mix, but copper is not one of those. So if we had copper plus, then that would be named copper 1 ion. The reason we have to do that is because if you just said copper ion, you would go and say, okay, well, copper is Cu. You'd look on the periodic table and you can't find the charge on the periodic table, so you wouldn't know what the charge was, unlike the other ones. So that's why we have to say what the charge is, regardless of what number it is. To name our anions, ones with negative charges, we're going to name the nonmetal and then just change the ending to "ide." So instead of being chlorine, it's going to be chloride ion. Or instead of oxygen, it's going to turn into oxide ion. So the only thing that's different is it's going to be IDE, which tells us that it has a charge. So let's practice some of these. So first we find it. There's S. Here's a hint. If it has a negative charge, it's going to be over here on the nonmetal side. And if it has a positive charge, it should be on the left side or in the middle. So we know that we have 16 protons. And since it's a -2, I must have gained 2 electrons. And that was sulfur. So sulfur turns to sulfide ion. You'll eventually get used to seeing them all, but you definitely have to have the IDE in there. If you're off on the spelling a little bit, then that's okay. But again, you should have IDE. The next one, Al, is right here. And it's positive. Anytime it's positive, you say, is it group 1A, 2A, silver, zinc, cadmium, aluminum, or gallium? Since it's one of the ones we know the charge of, we would just say that it's aluminum ion. We have 13 protons, and since it's a +3, we lost 3 electrons, giving us 10 electrons. One more, Fe, is right here. It has 26 protons. Since it's a +2, it lost 2 electrons, so I should have 24 electrons. I go through and say, is it group 1A, 2A, silver, zinc, cadmium, aluminum, or gallium? Nope, it's over here. So that means I needed Roman numerals. So I write the name of the metal. I put the charge in Roman numerals. And then I just put the word ion. Go ahead and do these last 3 on your own. So here was nitrogen. It has 7 protons. It has a negative charge, so it gained electrons. It gained 3 electrons. And nitrogen turns to nitride ion. K is here. It has 19 protons. A positive charge means it has lost 1 electron. So it now has 18 electrons. And it's in group 1A, so it's just potassium ion. And then finally, zinc is here in the middle. It has 30 protons, a positive 2, so it lost 2 electrons. And it's in group 1A, 2A, silver, zinc. So it's one of the ones that we know the charge of, so it's just zinc ion. Go ahead and pause the video and do these next 3 on your own. Restart when you're done with those 3. So here was nickel. So it has 28 protons. A plus 2 charge means it lost 2, so you had 26 electrons. It's not in group 1A, 2A, silver, zinc, cadmium, aluminum, or gallium. It's not one of those, so we needed Roman numerals. So nickel, 2, ion. Oxygen is over here. It has 8 protons. It has a negative 2, so it gained 2 electrons. And since it's negative, we're going to change the ending to IDE. So oxide ion. And finally, lead is down here. It has 82 protons. It has a plus 2, so it lost 2 electrons. So lead is not group 1A, 2A, silver, zinc, cadmium, aluminum, or gallium. So all positive ions, if it's not one of those that we just named, we need to write the name of it, so lead, and use Roman numerals to indicate the charge. So lead 2 ion. So all these with Roman numerals can have multiple charges. Lead can be a 2. Lead can also be a 4. Nickel can be a 2 or a 3. So any of the ones that we're using Roman numerals for, it's because the charge changes. Go ahead and pause the video and do these next 3 on your own. So F is here. It has 9 protons. Negative 1 means it gained an electron. And so we're going to change the ending to IDE, so fluoride ion. The next one is Mg. It has 12 protons. It has a positive 2, so it lost 2, so it's going to have 10 electrons. It is in group 1A, 2A, so I'm just going to call it magnesium ion. And the last one, phosphorus, is over here. It has 15 protons. A negative 3 charge means it gained 3 electrons. And since it's a negative ion, I change the ending to IDE. So phosphide ion.